Okay, fine. So, good evening, everyone. Welcome to the next segment of this workshop that we're holding. And this is basically on designing hospitals cost effectively. So, when anyone thinks of the word cost effective or cost saving, the first thing that they think of is either the cheapest way to achieve their goal or the most that they can, either stuff more beds into a facility or bring in locally available, really cheap materials and save costs in the short term basis and not actually visualize the long term saving of costs. What we must actually keep in mind is the hospital facility that we're setting up now is something that we would like to last for decades and decades to come. I'm sure every doctor setting up the facility would have the hope that their child or their grandchild will one day take over and run the facility. So this is a major long-term plan. And making short-term steps like a cost-effective material, which again, if there are specific materials, the location wise also it can change. Some material that is easily available here down south in Chennai may not be easily available somewhere in the north. So these are just fine-tuning tweaks and extra elements that we can do. But some shortcut methods to save costs that we have already discovered are ways in improving your design. Your design can be, your building itself can be planned such that you make most of the space available or make most of the facilities available. The main target you have to have is make sure everything moves smoothly and moves quickly so that you can always meet the demand. A major theme that came during Toyota's initial time in factory setup was a concept called lean. And that is what we are now going to link with our hospital designs to show how a smooth, lean, effective plan can really tighten up the process in your hospital and make things move much faster. So to begin with, the concept of lean. Now, lean, what they are trying to tell is this lean design can be achieved by making most of the facilities available and improving operations. That is what lean design is. And when you take it in terms of a healthcare design, it is basically saying improving care quality, efficiency, patient and staff experience, how by eliminating waste, that is wasted movements, wasted efforts, wasted space, improving productivity and increasing your end user value. That is basically your customers, which is the patients coming. Their experience through the facility is what our target is to make sure that a facility succeeds. So basically, lean is telling you that your design has to be efficient. Efficiency is the route to this success. So if we take it this way, the lean concept, you can, in our architecture terms, we will define it as designing or redesigning of a workflow that ensures elimination of waste in the process, thereby resulting in faster delivery of services to the patient. So whatever process we recommend, whether it is department arrangements, facilities within those departments, things should move smoothly, things should move quickly, and that is the only way turnover happens in the hospital. So lean concept. Now, what we have learned is lean has about 5 stages in it, which I will connect all of them to our hospital planning also. But now first I'll explain what these 5 stages are. First is value, value stream, flow, pull, and perfection. Value is basically the goal. What do you want to achieve in your facility? Like if we take it in our healthcare terms, it is what is our specialty you're planning in that department, in that hospital. That is value. Value stream is what do you need now to make that specialty happen or to reach that goal? What are the elements that are needed? Flow is connecting all these specialties together, how you will move through the specialties, how you will execute these specialties, putting them all together to achieve that goal which you're targeting. Pull is then perfecting this route, because when your value stream and flow run very smoothly, your demand automatically increases. And pull is basically demand. Your customer is the patients waiting outside. So the minute they know that there's a facility over there, there are services, these are the certain services they're providing, they immediately will come. If that is the demand at that moment, they will come. So next, your target is making sure the earlier 3 steps are running smoothly, plus tweaking it so that you still meet the demand, which will keep growing if you're moving well. So pull is the tweak that you will have to do to that demand that keeps growing. And perfection is your ultimate goal of everything runs smoothly. And then you add a little something extra regularly so that as the years go by, this process keeps improving. So it is not just the same stagnant position as you go, your process keeps improving as you upgrade. So now let's take each of these aspects and try to understand them in a hospital design and hospital planning point of view. Value, which is the goal, and value, this is a goal that is achieved from the customer's point of view. Now take us, for example, for us architects, doctors are the customers, but for doctors, the patients are the customers. So we need to take into consideration our doctors' requirements as, we need to take into consideration the doctor's requirements as well as the patients who will be coming to the hospital, their requirements also. So there are certain key points that we have to do, and we'll begin first with the patient's requirement of what is the treatment they're looking for over there. Like what Venkat has already explained in his feasibility study, we do a survey of the area and see what is the treatment in demand, what is not available, what is seen more. Like if that locality sees a lot of kidney issues, or whether there is no cardiac care facility available nearby. What is the demand of that locality? What are the people hoping for? That study is what we begin with always. And with that, we come with like a uh, top five specialties. Like, for example, like how you've seen here, it will not be a stark difference that there'll be cardiac has an 80% while everything else is 20, 30, 40. It will be a pretty close run. So for a successful running, you will need multiple facilities in a large hospital. So then maybe you will take the top 4 or top 5 facilities and try to work with that. So that is one part where you've got your requirements. Another part which we need to get from the doctors or whoever is setting up the hospital is what is their budget? How much are they ready to spend and how much is their capability of spending? So when we know these two, we will know how to plan. So in this part itself, you can save expense by, in case your budget cannot afford all those facilities, you don't have to begin with all. You just begin with maybe 1 or 2 of the facilities, let your hospital run, earn the required money, and let that fund the next 2 steps that you will take. So there is absolutely no rush that you have to start your hospital off fully in the first start itself. And knowing the demand, you know that even that one specialty you put, you have a demand in that locality. People will come to your hospital. You will break even whenever you have foreseen or whenever you've planned. The next step will be like how now that you know the specialties you would like and you know the budget you have, how to split this among phases. Now, there are many ways in which you can distribute phases. Like if you take in construction itself, you don't have to fully build and equip your entire facility. Depending on the budget, you can even decide that I will only build 2 floors and I leave the other 2 floors for a future date. Or maybe to make it a little more efficient, you will build the shell structure of the entire building. That is, like, for example, you intend about a 5-floor structure to occupy your entire hospital. What you do is you just begin with the ground and first floor with the first basic 2 specialties that you have thought of, and you just occupy those 2 floors alone. Let the structure be built, because later you don't want major knocking, breaking going on while you're still there, while the hospital is running. So let the structure be built, but keep it empty inside. You don't have to populate it. You don't have to equip it. You don't have to even do any interiors, nothing. Keep it empty. Use it like a store for now until you need the space, and then keep proceeding. This can even be thought of in many ways, like take an OT complex, for example. Now, when you've got like a 200-bed facility as your ultimate goal, you will need around 10 OTs, and all 10 will ideally have to be in the same space, in the same location. So now you can't split floor wise. What you can do is split them in half. Just execute 3 OTs in your first phase, 4 OTs maybe in your first phase, depending on what are the specialties you've taken, and close off, cordon off the rest of the space, seal it off so that there's no dust, nothing leaking through, and keep that for future. So when your hospital is ready to take on the next department, you build one more. And OT is the big advantage is modular is the way to go now, for sterility purpose, for cleanliness purpose, for maintenance, and best of all, installation. It is modular. It can just come. There's no major knocking, breaking, nothing. They'll come in and out, and your OTs will be set up in that process. So this is a way you can phase out your department. So if OTs have to be built like this, or if your diagnostics ultimate goal, you need 2 CT scan rooms, for example, but then you can't afford two CT scan machines to occupy only one room. Leave the other room next to it because plan-wise, you need it right there. You can't have two CT scans in two totally different locations, but keep it next to it, occupy it later, buy the CT scan machine later, which again, Suresh sir will explain in his part of the segment also on how you can separate the stage-wise distribution of equipment. But then basically in the plan, all this has to be considered. Your phase-wise distribution, your stage-wise distribution, department arrangements, because the minute you decide to stagger it in stages, you have to plan accordingly. Your lift and staircase positions, your IP rooms, because now you'll have departments coming above the IP rooms. All those have to be very well planned. And then, of course, you keep your eye out on the future. Future is a big question mark on what departments you want, but you might have a rough idea that maybe if my hospital does well, I'll buy the plot next to my hospital, or I'll buy the plot behind my hospital. If that type of a dream is there with you, then you need to consider that in this plan itself, because you will want in the future a possibility to connect your two buildings. So automatically you'll have to plan your corridors accordingly, place your staircase lifts accordingly, so that in the future point, your plan still runs smoothly when the new building comes up behind. So here again, you're saving your cost by spreading all your expenses across those phases. Your construction cost will get spread, your equipment cost will get spread. In all these phases, little by little only you'll have to. So actually your budget is towards your first phase, and then your hospital itself makes the required money to feed into your next few phases. Then comes value stream. Now, value stream again is putting together to meet your dream. So value stream is your departments. Now, you take ortho, for example. Your survey has shown ortho is the top specialty that has to come. So then you need your diagnostic equipments like X-ray and CT, and you need good OTs, large size OTs for your surgeries. Or if it was cardiac, you will know you need a cath lab in there, maybe a CTVS OT along with it. So the selection of the specialty, what comes out of your project report and your feasibility study, will determine what departments will come in your facility. So correctly selecting this also will save expense, because you don't have to give unnecessary facilities. Now, suddenly in the middle of this, whether a mammography is actually necessary or not, whether you're thinking only of a master health checkup and giving it as, again, may be considered wasted, or any other facility. So you can plan everything, every single element that you put. You can even outsource some elements, like take your lab, for example. If you can't afford it, or if you don't have the space sufficient in that first phase, you don't have to have a full-fledged lab. Keep a collection center in your hospital, gather the samples and send it out. And you can tie up with a really good reputed lab, a good NABL accredited lab, and your work moves smoothly, and you don't have to think of the maintenance or the space or equipments or anything like that. You're again saving money. So always go as per your requirements. Just meet the need. No need to go anything extra for each of these. Once you've decided on your departments, your next step is how you will place these departments, which will be placed one over the other, which will have to be placed next to each other. You can take this chart itself, for example. Now, the most critical parts that have to be kept close to each other is your emergency with your operation theaters, and that with the intensive care units. Then the next level is to the diagnostics. So everything that you arrange has to be as per some sort of a proximity of what is the route your patient has to follow. Now you consider a visitor who walks into your hospital. They will enter into the lobby. So you need your waiting area there. The OPD consultation room should be nearby. The diagnostic should be as close as possible. These three are where your OPD patient and visitor will be moving through maximum. Pharmacy should be near that. So all these kept close will avoid people from roaming around, from asking your staff for directions, from distracting people going into areas that they're not supposed to go into. So keeping the distance short, they will go quickly, finish their consultation, do the scan, come back. That way your one patient is done. So even if you've got 50 patients waiting there in your waiting area, if the process between each step is quick and fast, they will get through. Your turnover will be very fast. So if they have to be sent to the next building where your scan center is, then the time they take to reach there, then they'll wait over there, there'll be another queue there, they'll go in, then the time they take to come back, that is delayed. You could have done about 3 patients in this gap. So that has to be very well organized and very well planned. So simple short travel distances between each of these departments will determine how quickly people move through your department, and that will give you a chance to take in more patients, earn more revenue in that process. And then, of course, when you have certain departments close to each other, they can share their facilities. Like, for example, if you have the CAP and the OT complex maybe put together in one unit, you can have the same change complexes, same sterile, the whole zoning process, the sterile corridors, your sterile supply units, medicine supply units, all that can be common for both. Or if you've got the labor delivery and your operation theaters close by, in case of any urgency or emergency during a natural delivery, they can quickly move them into the operation theater, saves lives. So proximity and the travel distance are very important to save the expense, to make more, to make sure that there's a smooth running of all the functions in the hospital. Next comes the value of the flow. That is now your earlier step, you've decided on the departments. Now it is on how you will move through these departments. Now the main thought in this flow is it should be uninterrupted, smooth from beginning to end. There should not be any obstacles or any reason to divert from the path. So there are 2-3 aspects to look in this. There is the traditional unidirectional movement, which is followed in every single hospital. There is navigation signage, and there is uninterrupted movement through the space. So let's take unidirectional movement first. These are mainly seen in your critical care areas like your operation theaters, your CSSD, all the ICUs. All these spaces need the zoning, the sterility. It's very important. So here, what you're actually saving doing this unidirectional movement is you're preventing any infection from spreading. Now, a patient has come to your hospital for a certain surgery or certain treatment. You don't want them to acquire any other infection while they're there in the hospital. If your doctor or your staff or your nurse who's just come into the OT complex has just skipped the change and has walked directly into the pre-op or directly into the recovery, they are carrying infections with them. They're carrying their outdoor clothes with them. They're carrying shoes with them. Even a minor thing like maybe putting your doctor's lounge, which many doctors ask for, if that lounge has the facility to eat and has a toilet attached and all that, and if it is put within your sterile corridor, which is your OT corridor, that is also not good, because the food entering in, you have no idea what is there in it. And with a toilet there, a toilet is a source for infections also. And that is something that will cling on to the doctor, cling on to the staff or whoever it is, and they will come and they will spread it to the patient. And these are taken as negligence cases. So when such things happen, it automatically increases your patient's stay in the hospital unnecessarily, because as everyone knows, you don't want the patient actually staying there longer than they have to. All the money a hospital earns is mainly in the different treatments they do. So patient gets extra another infection over what they already had. It increases their stay. It makes them maybe want to file a case against the hospital itself for negligence and for causing something like this to happen. So sterility, maintaining that cleanliness, making sure that the movement is in unidirection and is through like a semi-sterile, sterile, and then exiting out also will save a lot of lives. Then, of course, comes the navigation and signage. This is a very simple concept. Make sure there are enough signboards throughout your hospital such that a patient or a visitor does not have to ask for directions. They should be able to go from one point to another without actually having to stop a nurse or an attender or someone nearby to say, can you please guide me? And here, the main way you're saving expense is by not having to appoint extra people just to, take them around, to take them to a certain location. Because if it is a very complicated route, you will have to appoint someone over there to do it. So in case you've got simple directions, again, short distance, simple directions, clear signages, the visitors themselves will move smoothly through the space, will not venture into staff areas which you're not supposed to enter into, restricted floors, OT floors, for example. All these you need to have your clear-cut boards, restricted entry boards, or the direction to whichever place they're supposed to go. They should not have to stop any any attender, any nurse, staff, anyone, distract them, cause an extra load on their thing also by asking them to take them to wherever they need to go. Then, of course, is the uninterrupted and smooth movement through the facility. So now this is basically, I know many people question why hospitals need wide corridors, and I have actually in earlier presentations also explained that wide corridors are mainly for smooth movement through it. Patients should be able to cross each other. You can't have to, stand behind someone else who's pushing a wheelchair that, kind of wait for them to pass and then only go across them. So that to avoid that type of traffic is why it's always recommended for hospitals to have large corridors. Another thing which is very common here in hospitals in India is people tend to wait on these corridors also. Yeah, the hospitals themselves finally end up putting chairs there so that people can wait. So keeping them seated there will again cramp up the corridor. Again, you can move only in a single line. One stretcher goes in one direction, no one else can actually move from the other direction. So corridors, keep the waiting there if you really have to, but then make the corridors wide, may give enough space for people to move across, not actually clog up the corridor. And here you're again saving time, you're saving money, you're making them go to different departments faster, you're preventing accidents from happening. Like if, for example, you set up a ramp, you've done the good step of having a ramp in your facility, but you have not taken the extra measure to maybe make sure there's handrail on both sides, or maybe make sure that the flooring that is used is not slippery, then again your purpose is lost. A slippery floor and on a ramp with the patients who are walking, there will definitely be falls. There will be people who will fall. They will either fracture their arm, they'll fracture their hip. Older people, it can be even more serious. And this is as bad as those hospital-acquired infections. You have hurt yourself falling in the hospital, which is the hospital's fault, which again, most of these, maybe the insurance and people may not cover it because these are avoidable errors that have happened, and the hospital will have to take full responsibility for any of these errors that have happened. So these are certain uninterrupted and smooth movement through the facility is a major booster to what you've already provided. You've given a corridor, it's got a good width, you've given a ramp, it's got the right dimensions and slope. Make sure it's clear, make sure it's neat, make sure the floor is anti-slip type floor where you get the grip as you walk down. Make sure there are handrails. Staircases also need handrails on both sides in hospitals. So make sure all those necessary elements are provided just to avoid a future much bigger expensive damage happening. Then we come to the topic of pull. Pull is basically the demand. It is the patient's demand that when they enter that facility, they see the facility, they understand what are the features available, they understand what are the specialties being offered, so they automatically come. And when they come, they automatically create a demand. So now you've got a good facility, you've got the necessary elements over there, your CT scan, you've got an MRI, you've got a cath lab, everything necessary to meet. You've got the flow also, your OP consulting, diagnostics, your IP rooms, all that is there. Now it is mainly tightening up the processes through that so that you meet this pull or meet this demand that is coming. And this is the demand that if your hospital is a well-running hospital, it will pick up very fast. And any slowing down of meeting this demand will clog it up, and then people tired of waiting will end up going to another facility. So the main thing that you have to consider is eliminating anything wasted. So that wasted can be considered in the form of wasted movements, wasted space, wasted support facilities, store areas in totally random places are sometimes not necessary. Stores are a very useful part of a hospital, but it's not necessary in some areas. So now if you take your OPD clusters, for example, depending on the type of specialty you're choosing, depending on the type of specialties handled by the hospital, there are multiple ways of arranging these OPD consulting rooms. Either you can have a nurse station in one end and all the exam rooms in a row with a large waiting space in the center, and this nurse station supervises everything. Or you can have the nurse station positioned somewhere in the center so that in case of, the nurse can quickly go to any of these consulting rooms and they can immediately have quick access to the patient also. So again, their travel distance has been reduced by that small shift into the center of that cluster also, center of that whole space also. That again saves time. It saves space, it saves time, it makes sure that the nurse has their attention on every single person around also when you're in the center of the space. Then, of course, an even better modification is clusters. Now, for example, you're like a 300, 400 bedded hospital who's doing cardiac, ortho, neuro, and different specialties. Best would be to club these specialties together. Cardiac specialty, you've got about 5 to 6 consulting rooms with its own small nurse station and waiting area. So then everyone just roams around that small box alone. So within that cluster, they will have about 2, 3 consulting rooms, plus maybe your ECG, echo, all that in that place itself. TMT can be provided with it so that, they don't have to actually roam around to other parts of the hospital, get their test done, and then come back here. That is unnecessary. So then when everything gets clubbed together in one location, that saves a lot of time, that saves a lot of nursing travel also, because now you've got a patient who can't walk properly, you'll have a nurse going along with them. Okay, now we'll go to the x-ray down below, and then we'll go to this part in another end of your hospital. So to avoid that type of thing also, you club them in clusters. So then in a bigger hospital setup, clusters is a very useful way to organize your movement, to restrict your people movement, to restrict your staff movement. Having dedicated staff to that cluster, yes, it's an added expense for the staff, but then it still ensures quick function from the staff itself, that the turnover again increases. Each of these clusters will be an ecosystem of its own, and it will keep bringing out more and more patients as the time goes. Then another part of that maybe that you can look at is your staff movement. Now this earlier OPD clusters, how your patients will move through the space. Now thinking of how your staff will move through the space, like take an IP floor, for example. You've got a floor with around 20 to 30 IP rooms in it, and the nurse station is positioned somewhere in the center of that floor. And that large nurse station has to look after all those 20 IP rooms. Plus, they've got certain stores in awkward corners. When we've got an awkward corner where an IP room can't fit, we'll end up putting a store over there. So a store over there, or a sterile supply unit somewhere, a dirty utility somewhere. The problem by doing that is that nurse has to now travel to one room, and then from there travel to a store, from the store travel to another utility place, go to another medicine place, get back to the room, go back. That is a very long route for that nurse, that particular nurse. And while that nurse is occupied with that particular patient and their requirements, she cannot answer a call coming from somewhere else. And then another nurse is sent off there. So then there is a lot of movement going on. So one way you can look at this is, how about splitting up that large nurse station into 2 small nurse stations? Keep it in 2 opposite ends, so that each nurse station is made in charge of a certain section of the IP floor. So they'll have to take care of those patients, and the other nurse station has to take care of their own set of patients. So 10 and 10 you split among both. And each of these nurse stations should ideally either in the center of that floor, or ideally attached to them, should have each of these storerooms. One clean utility, one dirty utility, or anything, med store, anything that is needed, attached or right there next to them, so that whatever is necessary, they can quickly take, quickly respond. So that way the response to a call from one of the IP rooms is also very fast. And over that, they will move between the spaces comfortably. They will not get exhausted. They will respond fast. And the number of staff, with that itself, you can keep the turnover again. Now your patient is over there. It takes a long time for them to get that day's meal, or for the patient to get that day's medicine. And then it's a disgruntled patient. They are not happy with how things turned out, and now they have to stay here longer waiting for their discharge summary to come and reach them, or any of those type of issues is clearly avoided when you've got a small nurse station, where just the press of the button and in a minute the nurse is there, right there at your door, asking for what you want. And they also very quick to come back also, because everything is nearby. This is also another version of the cluster arrangement, where in that cluster, that nurse station plus their 10 rooms and their required support things are all in that one short distance, short travel time space. So this way you're saving a lot, because one thing is, of course, your patient flow between the processes has improved. The patient doesn't have to travel too much. So again, they don't slow down the whole, you take a long time to reach the X-ray and then the X-ray is occupied. So then they have to wait and then the next person will have to wait because again, this takes time. So the patient flow is less. The patient gets faster service. So then they are happier. They move through the space faster. They go out with a good opinion of your facility. Again, word of mouth is what gets you a lot of patients also into your facility. So you keep your patients happy in that process. And also this saves the this saves your staff's exhaustion also. They don't get too exhausted and then they don't, otherwise you'll have to appoint another two people. Your nurses themselves will come and tell you that, no, I cannot take care of 20 rooms in this way because it's difficult. So then you'll have to appoint fresh staff to take care, to help them out in those requirements. So arranging rooms can save in those expenses. Then next, of course, is patient comfort. This is after all for the patient that you are setting up this facility. And the main key aim for this is to reduce the length of stay. They should not have to stay there more than necessary. Like how we discussed before, your doctors and hospitals make money in the treatment, not in the IP room occupancy or not in the stay of the patient. So you need to quickly get them into the IP room, let them heal, and then quickly get them out. So for this, you have to take some conscious steps. First thing, of course, is preventing hospital-acquired infection, which earlier we had mentioned in the unidirectional movement. But apart from that, it's things like hand washes in close proximity so that you can, the doctor makes sure that doctor or nurse or whoever is visiting, make sure that they wash their hands before actually treating a patient or between two patients. If that hand wash wasn't there, they are not going to take the extra effort to go to a bathroom, wash their hand, and then come back. No, they will go to a hand wash only if it is right there for them to quickly access. So that, or how you arrange beds in a ward, for example. Now you keep two beds very close to each other, maybe just 2 feet apart. There is a very good chance that one patient A will contact some infection from patient B or vice versa. So when that happens, that is again going to be an extended stay, again going to lead to further complications. So you should have a very clear and clean distance between your patients also to prevent cross infection. Then, of course, giving the extra patient-friendly facilities or your disabled-friendly facilities to prevent falls. That is your grab bars in toilets, your grab bars in rooms also. Nowadays, there are even more in that. Elderly facilities have those that hang from the ceiling, which you can hold on to and move out with. Your patient-friendly toilets, even in among your public toilets also, so that in case as a wheelchair visitor, nothing happens to them also. Your corridors having handrails, all those extra patient-friendly measures need to be taken to keep the patient safe in their space. Then, of course, make an environment conducive for them, provide large windows. This is something that has been proved also, that large windows are useful in helping cure patients. And this can be done in your IP rooms by maybe instead of putting your toilets on the outer wall, put them on the inner wall. That a toilet does not need the ventilation outside, and the exhaust that you provide for your, the cost you spend on that exhaust, artificial exhaust for that toilet, is nothing compared to the cost of actually having a patient recover quickly and leave, or the natural light that comes in through the large window. You're saving a lot over there also. So you need to consider patient comfort also as you plan the space. Give them all their necessary facilities, keep them happy. No need to tighten up, cramp up the space that they can't move, put them against the wall that a doctor can't actually, treat them quickly in case of any emergency. All these little things have to be kept in mind. Then last but not the least is perfection. Perfection is actually making sure that you have now the first 4 steps that you followed have been running smoothly, have been running very well. That is great. Now it's time to go that little extra and put something more into your facility. And these are optional ideas which you can think of when you reach a point where you can afford something like this, because all these, of course, they are good ideas, but they are cost centric in the first step. Where you first actually install this facility, it is an expense, but then on the long term, it is a great saving. So your solar energy, solar panels on the roof, so that they can take care of, maybe begin with just the water heating system, maybe, and then maybe if it starts working much better, it can take care of the cooling system also in your hospital. your rainwater harvesting, because there are many cities in India that face major water shortage. So rainwater harvesting is something that you're doing not just for yourself, you're doing it for your community as well. And your whole water purification, water treatment plants, where your sewage waste, that water generated from that can be used for other things. You're watering the garden, cleaning, washing, any of those flush water is usually these water that has gone through your water treatment plant. So this is that extra something that you can add and save money. Of course, you're using renewable energy, you're reusing items. So you obviously save money in that. And then your last one, natural ventilation. Now in India, I mean, there are many hospitals. We have also had many clients who are much smaller hospitals who need not actually air condition their entire facility. You make sure that your critical areas are properly air conditioned. Your IP rooms can still have openable windows, natural lighting, natural ventilation, all those necessary. So that again saves money. You don't have to install, those smaller hospitals don't have to actually do a full-fledged air conditioning system in your IP rooms. And your natural lighting will save a lot on your electricity, of course, for the lights. During the daytime, you don't have to have your lights on. Corridors, if they end on the exterior wall and have a large window there, again, you're on your electricity bills you're saving using natural lighting. Waiting areas, open it out, give it lots of natural light in. You need not open the window to let air in, you air condition the space, but the light is always a welcome thing. And of course, in patient rooms, doing that extra, giving a comfortable family zone and giving a good acoustic sound absorbing tiles or anything, the extra mile. That's what this perfection is. You do something a little more so that in a daily basis or in a yearly basis, you're taking your hospital again a step forward. So these 5 steps, these 5 processes are the lean theorem, lean theory, where it's already been proved in factories, and now it's already being proved in healthcare facilities also, that tightening and perfecting your process will be an immediate result in your functioning and your efficiency on how you run your facility. And that will, of course, help you save expense, save cost, cut costs, all your processes. So I hope this has been useful. And of course, next Suresh sir's presentation also will cover everything necessary in equipment. So then I hope a combination of all these three will help everyone know how to achieve what they need to in their budget. Thank you.